In lesson 27, we're looking at rational expressions. Our first example, we're adding 4 over x plus 6 over x plus a. Our first step is, as usual when we're adding fractions, is to find a common denominator. This time we have variables as our common denominators, but we use the x by itself from the 4 denominator, and then the x plus a from the denominator of the 6. So we're usually using all the elements we have, and really many times we end up just multiplying them together as we're doing today. Now the 4 doesn't have the x plus a, so I'm going to have 4 times x plus a. And I'm going to keep that as a plus. And then the 6 doesn't have just the x by itself, so I have to multiply the 6 times the x. And I'll use the distributive property with the 4, so I'll have 4x plus 4a plus 6x all over x times x plus a. Now I have like terms in the numerator, the 4x and the 6x, that I need to combine together. So I'm going to have a 10x plus 4a, and that is all over x times x plus a. And then that is our answer. We'll just leave it like that. The next example is very similar. We're adding, and we've got variables in our denominators, so we're going to have to include them in the common denominator. So we're going to have an x squared. The 6 only has that understood 1, and 1 times an x squared is still an x squared, so we don't really have to worry about the 1. And then we'll have an x plus 4 that we need to include. So the x plus 2 had the x plus 4 but doesn't have the x squared, so I need to multiply that. So I'm going to have an x squared times my x plus 2. And the 6, well, it needs all of it. It needs the x squared and it needs the x plus 4. So I'll have 6 times x squared, and then in parentheses the x plus 4. And then the 2 had the x squared, but it didn't have the x plus 4. So I'll have a plus, it'll keep the same sign. 2 times x plus 4. Alright, now we need to go ahead and use the distributive property with those terms that are outside the parentheses. So I'll have x cubed plus 2x squared, and I'll go on to the next one. That's plus 6x cubed plus 24x squared plus 2x plus 8. That is all over the x squared times x plus 4. Alright, now we need to get our like terms together. So I've got x cubed here and x cubed here. And I've got this x squared and this x squared that need to go together. So I'll have 7x cubed, so I've used those. And then I'll have plus 26x squared, so I've used those. And plus 2x plus 8. That is all over x squared times x plus 4. Okay, and then we just leave our answer like that. Alright, our next example is another one where we have variables in the denominator. We're adding rational expressions, but this time we're going to need to factor the denominator of the x plus 2. So I'll keep the x plus 2 the same. I'm going to take that trinomial and factor it into two binomials. So an x times an x would give me the x squared. And then factors of 3, well, that's pretty easy. It's a prime number, just 3 and 1. It's positive, so they're both going to be the same sign. And then this is positive here, our middle term is, so that means they're both going to be plus signs. Right? And then we're going to have our next term. We don't need to factor it. It can just stay as it is. Alright, now we kind of assemble our common denominator. We need the x and the x plus 1. They both have 1 of the x plus 1s. So I'll have x times x plus 1. But I also need to include this x plus 3 times x plus 3. Alright, the x plus 2 needs to be multiplied with the x of x times x plus 2, and then minus, the 1 didn't have the x plus 3, so I will have to include that. So x plus 3, and then put that 1 on the outside, and then we'll use the distributive property. So I'll have x squared plus 2x minus x minus 3 all over x times x plus 1 times x plus 3. Right, now I need to get my like terms together here. So I'll have x squared plus x minus 3 all over x times x plus 1 times x plus 3. And then that is our answer. We're going to leave it like that. Alright, those can be a little tricky, especially since you have to factor before you find the common denominator. But with a little practice, they'll seem much easier.